today we are doing trigonometric ratios. Say that with me. Trigonometric ratios. Alright, so last thing we did, well, first thing we did, we talked about Pythagorean theorem. For Pythagorean theorem, it has to be a right triangle. You have to be given two sides, and then you find the third side. Special rights. It has to be a 30, 60, 90, or 45, 45, 90. You're given one side, and you can find the other two sides. Trigonometric ratios are the best because it has to be a right triangle, but you only need one side and an angle, or two sides, or so you can find angles and sides with trigonometric ratios. Alright, so trigonometric ratios is a ratio of two sides of a right triangle. So you don't have to say trigonometric all the time. You're going to hear me say trig more than anything else. I need you to know what some symbols are. This is theta. And it's the symbol for an angle. Calculator, your calculator has to be in degree mode. You're definitely going to need a calculator when you're doing homework in trig, okay? So talk to me about that in class tomorrow. Alright, calculator must be in degree mode. Not radian. If you see radian, you're going to get the wrong answer. Alright. We're going to write all the flat parts, and then we're going to go back. So this green one, or your second one, is going to be sine. Sine is opposite over hypotenuse. Cosine, and this is not sin A, is sine, is cos adjacent, and hypotenuse. Press pause because I'm going to move this, I'm going to erase this. Alright, so the third one and fourth one. Okay, the third one is tangent, which stands for tan, opposite, adjacent. Just make sure you have your notes written down. We're going to go over this a lot. Well, some practice problems in class. How to find a missing side. Press pause again if you need to. I'm going to go up. How to find a missing angle. Alright, for the flaps, we're going to go flip up the first flap. Okay, so you should be writing on the one that has sine at the bottom. Alright, sine theta, that is not sin, that is sine theta equals opposite over hypotenuse. So that cut in the corner. So if I had this triangle and this was my angle, my theta, this would be my opposite. This would be my hypotenuse. So we're just going to write ratios. Remember, ratio is just a fancy word for fraction. Okay? You're not solving for anything. You're just writing a ratio. So example, find sine J. Alright, so sine J, whatever is next to the trig function, so whatever is next to sine, cosine, or tangent, is your angle. So since it says sine J, that's the angle I'm worried about. So I want it to be opposite over hypotenuse. So if I'm at J, what's my opposite? 4 would be my opposite. And then my hypotenuse will be 5. And sometimes they want you to leave the ratio as a fraction. Sometimes they want it as a decimal. So that says sine J equals 4 over 5 or 0.8. Okay, cosine. So flip it up. This one should be on the top of cosine. We have cosine theta equals adjacent over hypotenuse. What does adjacent mean? We talked about adjacent before. What does adjacent mean? Okay, so adjacent, remember, means right next to, okay? So we're going to do cosine theta, which equals adjacent over hypotenuse. So for example, if this is my theta, of course this is my hypotenuse, and then the side that's next to this angle would be this side, and that's my adjacent. So let's do an example. Okay, so it says cosine J, so remember J, whatever's next to my trig function is my angle, so J is my angle, and cosine J equals adjacent, so adjacent to J would be the 9, and then the hypotenuse would be the 15, which I can reduce to 3 over 5 or 0.6, and I'll tell you if you were doing a problem if I want it as a fraction or as a decimal. Move on to tangent. So this should be on the top of the tangent one. Tan theta equals opposite over hypotenuse. So if this was my angle here, this side would be my adjacent side, and this side would be my opposite side. Example. So again, J is my angle, so you start from angle J. So for tan J, I need to go to my opposite, which would be KL. Oh, I didn't put the numbers, y'all. Y'all could have told me I ain't had enough numbers. So my opposite would be 16, and then my adjacent side would be the 12. Adjacent, opposite. So then that reduces to 4 over 3 or 1.3 repeating. 4 over 3. guys. You're doing good. You're doing good. Okay. We're going to the how to find a missing side. I have steps. So I'm going to type them up. And so you're going to, after I type them, press pause so you can write them down first. Okay. Alright. So the steps. First off, you always start from the given angle. You label all your sides, your opposite, adjacent, and hypotenuse. You figure out which trig function you need to use for SOHCAHTOA. The S is sine, C is cosine, and the T is tangent. SOHCAHTOA is a way to remember the formula. Sine is opposite of hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Again, that is SOHCAHTOA. Then you set up and solve. If x is at the bottom, then you switch places with the trig function. If x is on top, then you multiply. Okay, we're going to do 2 examples on this same page. Okay, on how to find a missing side. Again, press pause if you need to press pause to copy all that down. Example 1. Alright, so steps you would take. First step, always start off from your given angle. What's given to you? What angle is given to you? 15. Label all your sides. The 15 is my angle. This is my opposite. This is my hypotenuse. This is my adjacent. Figure out which trig function you use. They gave me my opposite. And I'm looking for BC, so I'm looking for my adjacent. So if I'm thinking about SOHCAHTOA, you don't have to write this part down because you should already have it on your notes at the top. The one that has opposite and adjacent, that's the TOA part. So that's tangent. So I'm going to do tan, theta. Theta stands for angle. 15 is my angle. Equals opposite, which is 10.2. Over adjacent, which is, I don't know, which is x. So then in the 4th step, that was my setup and solve. I told you if x is at the bottom, it switches places with the trig function. So x equals 10.2 over tangent 15. And then you'll be able to put 10.2 divided by tangent 15 in the calculator. You get x equals approximately 38.1. Okay, we're going to do another example. The second example is on the same page. Same page. So still finding the missing side. Okay, pause if you need to draw the picture. Alright, so I'm starting from my given angles, which is 63. Labeling my sides. So this would be my opposite. This would be my adjacent. No, I'm tripping. That's across from the 90-degree angle, so that'll be my hypotenuse. And this would be my adjacent. So I was looking at SOHCAHTOA. They gave me my hypotenuse. I'm looking for my opposite. Opposite and hypotenuse is so. So I'm using sine. So sine theta. So theta is my angle. So sine 63 equals opposite over hypotenuse. If the x is